Thank you for making it to the last session of the day. Like, I know that the only thing between you and beer now is me, so I'm going to get through it quite quickly. Hopefully you are in the right room. Well, yeah, exactly. Why doesn't everyone else have beer? Setting a fine example. Hopefully you are in the right room. You're here to learn about metrics and application logging and how it can help you. This is me, I'm Michael. I'm mheap on Twitter if you want to say nice things about the talk. If you want to say bad things, don't put that on the internet. Just come and talk to me afterwards. I was a PHP developer for about 10 years. Then recently moved into operations land where monitoring and metrics is a lot more important. And that's why I come to give this talk to developers. To say, I was one of you once, I didn't really get it, but now that I'm on the receiving end, it helps so much. We've got quite a lot to get through, so we're going to dive straight into it. But I wanted to give you a quick rundown of what we're going to cover. Today we're going to cover a few different things. We're going to start by thinking about why we need to log, what logs we currently use, and things to consider when putting the log together ourselves. How to get started, what to log, where to log to, how to add it to your application. We'll cover the ELK stack, which is the Elasticsearch, Logstash, and Grafana. It's the de facto standard for application logging. I'll take a look at what each component of that does and how it's useful to you. Logs and dashboards go hand in hand. Sometimes you don't have hours to read 10,000 log messages. You just want to see a nice graph that shows you what's happening. There are a few pitfalls when it comes to log management, but don't worry. We'll run through a couple of the most common ones. I made those mistakes, so you don't have to. And finally, almost finally, we're going to take a look at some supporting tools, things like Beats and Pagerduty, before ending it off with a conclusion. Sound good? Cool. So logging. Why do we log? All the way through this, feel free to shout out. Why do we log? Debugging. What went wrong? Always the first one that comes out. Why else do we log? Metrics. Who visited us? How many people visited us? Any more? I heard accountability. Audit logs. Who gave Michael access to production? Because, well, they need firing. But if you don't have an audit log, you don't know why decisions are made, why things happen. And I like to think of it as runtime documentation. Your application log tells you what your application's doing right now. Without it, you have no idea what your app's doing. Once you've shipped it to production, it's just like a big black box. Being able to log into a server, run tail-f, and just read what your application's doing, what queries it's running, what pages are being hit, things like that is so useful. Imagine if someone said, hey, it's not working, but I don't have anything to give you. Like, where would you start? And that's why an application log is so important. So, I see it in your eyes. Like, we're done. You're all sold. You're going to go into work tomorrow. No. You're coming here tomorrow. You're going to go into work on Monday and start building an application log. You're sold. But I know what your next question is as well. It's always the next question. Can I have it for free? Can I have it without doing any work? And actually, yes, you can, for a lot of it. I mean, you use Apache, you use MySQL, you use PHP, you might use Chef, OpenSSH. All of these libraries, all of these tools have application logs. They write out what they're doing to disk, and you can just go and you can read it to find out what these applications are doing. You want to enable the slow query log in MySQL to find out what queries are taking the most time. You don't have to change your application at all. It's basically free. But that doesn't help my application. Unfortunately, you are going to have to do a little bit of work here. There's no easy fix where an application log just magically appears for you. You have to put in the work. But we're going to do it together. We're going to go through all the different things you might need. Before we get started, I want to make sure that we know that there are two different types of logs, both very important, but both very different. The first is the log for humans, and ideally this should be silent. This is really for the database isn't there, or I ran out of space on disk and couldn't mount the image. It's things like that. This is your error log. These are things that you really care about, and you don't want it mixed in with tons of other debug information. And the other kind is machine readable, and this is probably going to be JSON. It has a defined schema, ideally versioned, and this is for things like a media object has been played. I'm going to log that that's been played. You can use that for accounting purposes later, whatever you want. Now, I used to think this was true, but since I moved from development to operations, I realised that there's not really two types of log. There's two different purposes. One's for humans to consume and work out when things go wrong, and one for machines to consume, like when a media object's played. But it's actually just one type of log, and that should be machine and human readable. I mean, I'm sure everyone here has sat down, taken a piece of JSON and said, well, it's a little bit messy, but I know what it's doing. And by using tools like JSON, or there's also log format is gaining popularity at the minute, you can read the machine logs. You might not be able to do it as easily, you might not be able to do it at a glance, but with programmers, we can write tools that consume JSON and output human readable information. It's much easier to go from machine readable to human than it is from human to machine readable. So my advice would be to always make sure that every log that you emit is machine readable. So, what's an application log? What should it tell us? It tells us what's going on inside our application. It gives us information to debug an issue. It gives us narrative information, calls to methods, event triggers. It tells us when a user sends the upgrade header and changes from a HTTP to a WebSockets connection. It tells you what's going on with your code. We've got business events. I said a media object being played. You can bill on that. Every time someone plays a media object, you get 10 cents. Or a tenth of a cent, it doesn't matter. What if you bill per login? Every time someone logs in, you want paying. All of these events can be done through your logging system. But what about when it's not just for accounting? What if you also log how many people successfully completed checkout on your e-commerce website? And it averages around 50 to 60 a second. That's not bad. And then you deploy, and suddenly it drops to 0, or it drops to 5 per second, or 3 per second. Wouldn't you want that information, that historical data, to say we average about 50 to 60, and be able to see that immediate drop? Like, that will show up on the graph instantly. No need for a customer to report, hey, only one of my cards worked when I tried 3, and you have to try and work out what's going on. Seeing on the graph instantly that something has changed is invaluable. I like to think of an application log as a story that signposts every twist and turn through your code base, through your application. When I started at my last job, it was a fairly complex system, and I had no idea where to start. Fortunately, it had a great application log. So all I did was I booted up the service, I made a couple of requests, and I read the log. I noticed, oh, when I go to this endpoint, this happens. When I go to this endpoint, this happens. And I very quickly worked out that if I wanted to do a specific thing, I had to look in a certain area of the code. Because I can search for log messages. They help me really zero in for what code is zero in on what code is actually running. So that was a quick introduction to why we need logging, how we should do it. But really, we want to get started. We want to go back to work on Monday and build it ourselves. And application logs always start with the 4 Ws. When did it happen? Who did it happen to? Where am I sending this information to? It could be a log file on disk. It could be an email to your CEO. If you're in an early stage startup and someone deactivates their account, that log message probably wants to get sent to your CEO. Like, they want to see that information. If the database goes away and there's an error, you probably want to get notified somehow as well. You don't just want it going to a log file on disk. Perhaps most importantly, why did it happen? And make sure to log the reason why it happened, not just the raw data. When your logs say that something's happened, it's really useful to be able to say it happened because the user did this or the user did that. And one of my favourite stories to tell here is we were trying to debug an issue that something worked sometimes but not others. Like, well, it's working sometimes, so the code must be doing it. It must be a race condition or something like that. And what it actually ended up being is the code wasn't sending the message that we expected at all. We had incompatible bindings and the message just wasn't being sent. But the reason it worked sometimes is because, unbeknownst to us, there was a cron job somewhere that ran every minute that pulled all the information just to synchronize state. And when we saw it working, it was actually that we tried to send the message 10 seconds before the minute ticked. So we added a reason. I'm regenerating the user information because I received the message. I'm regenerating the user information because of the cron job. And that problem went away. But honestly, we spent hours and hours and hours on this when just logging the reason why it happened would have made it really clear to us. So, getting started. Really easy to get started. Who knows this function? Yeah. All you need to do, take your code. This is my code. It counts the number of consonants in a word. I dropped in this error log function. It writes simple lines to wherever it needs to go. By default, it writes to standard out, which is fine for CLI apps. It's better than using Echo. But for web pages, this is better because it will log to the Apache log. If you don't want it to go there, you can change it. You can set this INI setting. And you say, write to for log myapp.log. And every time you call error_log, you get a line in there. There's not many pros for this approach. It's built in. But there's plenty of cons. Is it really semantically correct? Our message was more informational than it was an error. And our errors are getting mixed in with informational messages here. It's just not as powerful as we'd like. But it's still a lot better than nothing. So if you can go away and do this, start with this. Our other option is to use a logging framework. And this next slide used to be a slide that had Klogger, Zendlog, all of those on there. Just use Monlog. Like, I used to talk about all the different ones, but it's really not worth it. Just use Monlog, it's the best out there. You trust Composer? Well, Jordy did Monlog, same guy. And it takes a little bit more work to get running. First, we need to instantiate a Monlog instance and give it a name. Then we need to add a handler. And a handler is what tells Monolog where to send the messages. In this case, we're sending it off to a file in our temp folder, and we want to write anything at the debug level or above. And we'll cover the logging levels in a little while. We make a call to log.info, which adds a log line at the info level. Info is higher than debug. So it gets logged, and it looks like that. It's got a timestamp, it's got your app identifier, it's got the level and your message. And those brackets at the end are for additional metadata, which we didn't actually use. Job done. Like, we're now using monologue. Once you've done the bootstrapping, that single call is all it takes. But I'd hate to talk about monologue and miss out one of my favourite parts of it, which is the FingersCrossedHandler. What this does is it wraps another handler, and it's in control of when the messages get flushed to the first one. So it's a little bit hard to explain, but we'll go through an example. Here, we create a stream handler that says, I want debug and above. So I want everything, and I want to write it to a file. And then you've got this FingersCrossedHandler that says, actually, I'm going to take control of that stream handler that you've got, but I only want to log things at error or above. I don't want any debug or notice or anything like that. We buffer everything up, including debug messages, but we only log them if an error level is triggered. Like I said, it gets confusing, so let's just work through an example. In this situation, we say we want error and above, and we have an info. And our log file looks something like this, because it wasn't high enough to trigger. But what if we trigger an error? Something bad happened immediately after the info. If we were just using the stream handler, we could say, okay, I want error and above, and you don't even need to worry about fingers crossed, because you will only get errors and above. But what the FingersCrossedHandler will do is say, okay, I'm set to error, there has been an error, and it will log everything up until that point. That's why it's called fingers crossed, because you're hoping that nothing's going wrong, and if nothing does, your logs are empty. But the instant that something goes wrong, you have all of that debug information, you have all of that info level logging, and it helps provide context for what's actually gone on. Monologue has slightly more flaws than errorlog. It's an object, so we can inject it into our code if we want to. It supports multiple log writers, so I showed you writing to file, you can send to a HTTP endpoint, emit it to syslog, send an email, do whatever you want. And it has log level support, so you can say this is informational, this is an error, and again, we'll get to that in just a second. The only con for me is that instantiating an instance can be quite complicated. Passing it into all of your code can be quite complicated. So if you've got a huge legacy project and it'd be real difficult to use this, you might be better off with errorlog. For everyone else, just use monologue. And I mentioned the error levels. You can use whatever you want. Any PHP/JavaScript developers here? No, not so many. You use npm. npm has its own set of logging levels, completely different to anything else. And it actually has one lower than debug called silly. And honestly, people use it so much, and it just spams and spams and spams. If you do C++, you might be used to the trace level logging, things like that. Everyone picks and chooses their own, but they shouldn't, because there is no RFC for it. We should just use syslog. There are enough levels here to express your intent with reasonable granularity, starting all the way at the bottom at debug, info, notice, warning, error. I'm doing this from memory. Error, critical, alert, and emergency. Yeah, that wasn't bad. Most of yours will be somewhere in the middle, somewhere between informational and notice, up to error and critical. I mean, you can imagine you can't connect to your database, that's a critical error. A user signs up, that might be a notice. Alert and emergency are really reserved for the server administrators. For example, emergency is the server is physically on fire. So when you say, well, why can't I use emergency in my applications? It's an emergency, I can't get to the database. It's not. That's a critical fault, it needs fixing. It might even be an alert if you can push it, but it's definitely not an emergency. And Monolog supports the syslog levels, and coming up on 2 years ago now, I think, this was actually a topic of discussion for the PHP Fig, and they ratified this as PSI3. So if you like following the PSIs, this is in there. They provide a logging interface for you to work to that contains all of these levels. All you need to do is go through your application and decide what level each log message should be at, because you don't want too many in there, because you'll just never read them. But think about it. Is this informational? Is it something good that I should be aware of? That's a notice. Is it a warning? If I don't do something about this, is it going to transition into an error? Or is it critical? Can I not talk to my database? So we've been through our code base, we've added a ton of logging, we need somewhere to send it. So writing to a file on disk is good, but no one ever reads it. I mean, you ship it to production, you might not even have access to the server to see it. And this, for me, is the bit that's amazing. Imagine this, everything is on fire. Servers, buildings, everything. Would you want to go into the office and log into each server one by one and run tail -f on each log file on there, just trying to guess which server you need to look at, which application? Wouldn't it be great if there was just one place that you had to log into and look at? And that's what the ELK stack gives us. ELK stands for Elasticsearch, Logstash, and Kibana. But really, if we think about the order in which they run, it's like the LEC stack, but that doesn't have the same ring to it. I can see why they went for ELK. It starts with Logstash, and Logstash sits at the beginning, and we can think of it as a data bus. It has a range of inputs, some middleware, and some outputs. When I say it has some inputs, it has a lot of inputs. It can be a path to a file, it can listen on a specific port, it can pull data from S3 if you want. There are about 50 inputs, some more popular than others, but they're all available for you to use. Personally, I tend to use file the most. I also tend to use standard in, because who doesn't like piping data into a process? And also S3, actually, because we archive a lot of our log data, because we don't want to see it all the time. But sometimes it is useful to re-import that and try and work out why something happened with a little bit more information. So this is just the inputs. This is how you get your log data into Logstash. And once it's in there, you're really into the core of Logstash, which is its filter system. If you don't need this, you can use a more lightweight option, because Logstash is pretty heavy. It's written in Java, needs a lot of RAM to keep going. And there are lighter options such as beats, but they don't have any of this filter logic, or at least not to the same extent. And the filter looks something like this. And this is the easiest one. This is the JSON filter. It expects to receive a valid JSON document. It extracts each key from it, and you can add or remove fields as you want. You log sensitive information, but actually that shouldn't end up somewhere searchable by everyone. use Logstash to remove that field before it even gets to Elasticsearch. And this is great if your application is already outputting JSON formatted messages. Monologue can do this. It's got a JSON formatter. You can use key value logs, which is the log format. They're supported, and you can manipulate all the fields and do things like set defaults here as well. But really, the power of Logstash's filters comes here. It's called the Glock filter, and this is a line from OpenSSH. Someone's logged into a machine, and the Glock filter lets us tokenize arbitrary text and extract meaning from it. Here, I'm interested that a public key was used to log in as root from this specific IP address, and SSHD was running on port 22. To parse this and get it into something that's machine readable, you use something like this. And it can look pretty scary to start with, but it's really not that bad, because half of it is literal text. So things like accepted will match accepted literally. And then we say we want to match a word, and I'm going to capture that as auth_method. We want to match a user, we want to match an IP, we want to match an integer. And at the other end, this will pump out a JSON document that has auth method, username, source IP, and source port. And these are just named regexes. It comes with a ton of them built in. You can write your own if you want. But it uses word, user, IP, and integer. They're relatively simple, regular expressions. There's a fantastic tool called Glock Debug to help you put these together. You put in your unstructured text, you put in your Glock filter, and it highlights in real time as you make changes. It's wonderful. If anyone wants to try writing these, I wouldn't try and do it without this. And once we've got that data out, we've manipulated it as we want, we've got it in a structured format, we need to send it somewhere. And again, there's dozens of options, but most people don't use, well, any but one really. Most people send it to Elasticsearch. Every filter applies to every input and is sent to every output. You can do some clever things with tagging, but if you want different combinations of filters and outputs, the easiest way to do it is just to run a separate Logstash instance. Logstash can be pretty slow. It's actually really fast, but when you're throwing thousands and thousands and thousands of log lines a second at it, and it's having to tokenize them and generate structured data, it can have a hard time. Use as few Glock filters as you can. Make sure that your applications emit structured logs. Just minimize the amount of work that Logstash has to do. Like I said, you can send it anywhere. There's dozens of options, but everyone uses Elasticsearch. And Elasticsearch is a document-based search engine. It's got great full-text search capabilities, so ideal for log messages. It's great at aggregations as well. If you want to do things like build histograms. There's not actually much more to say about it other than you have to install it and run it. There's a few performance tweaks you can make if you hit issues, but most people don't hit those issues, at least not initially. We'll cover those at the end when we discuss the common pitfalls. There's not much more to say about Elasticsearch. It stores documents for you to search later. And finally, Kibana. Kibana is your search interface. It's a quick way to query Elasticsearch, to build dashboards, visualizations. It's actually kind of hard to explain, so I figured the easiest way to explain it is just to show you Kibana. And this is where everything crashes and burns horribly. You can see that? This is Kibana. And all of this is fake data that I imported. And you can click into it and you can see that the JSON's been tokenized. I made a request to billing. Probably can't see that actually. Let's make that bigger. Not that big. I made a request to billing. It came from that IP address. It was a 200. This was the original message. And you can do all kinds of things in here. So that's HTTP logs. I also have a lot of logs for business events. So I also imported a set of bank accounts into here. So I want to see the bank accounts for all males. And it returned it, and I see their balance, their address. But I want to do more. I want to say, show all males, and their balance is greater than 20,000, and their balance is less than 35,000. And these are questions you can ask after the fact. You don't have to think about these in advance and specifically log this information. Just throw all your data into Elasticsearch, and Grafana will let you search and see it. So here we are. We can see that Mr. Phelps earns, where's it gone? 21,153, which is between our search criteria of 20,000 and 35. Now imagine this for SSH logins. You want to see when people logged in as root, when Michael logged in, when Wim logged in, when people logged in using password. All of that is now at your fingertips. You can search and find that. But like I said, sometimes you don't want to read 10,000 log messages, you just want to see a graph. And Grafana has excellent visualization tools as well. So going back to our HTTP requests, I'm going to build a pie chart. And I'm going to say I want to search by endpoint. And there it is. We can see at a glance how many went to user times. But actually, that's not enough for me. I want to add another dimension to it. So I want to do it by, let's say, HTTP code. And now, for each endpoint, we can see how many 200s, how many 500s, how many 400s. That's useful. I like seeing by HTTP code, but actually I don't like the format it's shown in. So instead I want one pie chart per endpoint. So I want to split the charts. You can ignore the error message. And this is by endpoint. And I will just drag that to the top. And get rid of our other one. And now I get 5 charts, all broken down by HTTP code. So this one's billing. And look how easy that was. That was 30 seconds. We can do bar charts. We can say that our y-axis is the average balance of an account, and our x-axis is the state that the person lives in. By default there are 5. I'm going to up that to 51 so we get all of them. And there we are. We can see that Colorado, is that? Has the highest average balance. These insights that I'm pulling out just from the data that we're emitting from our application logs. And it's not just for application logs. If I change index to Shakespeare, I actually ingested the entire contents of Henry IV. Every line spoken. And I can search for every line that Gloucester says, just like that. And the same with visualizations. We want to build a tag cloud. Wants to do by speaker. Let's find out who has the most lines in King Henry IV. Oh, it's Gloucester. Hamlet has a lot. King Henry V has a few. Othello has a few. Imagine importing commit histories and things into this tool. You can do all kinds of things. And you can save these visualizations and build up dashboards. You can have 3, 4, 5, 15, 20 graphs that all match up, that all show the information. And at the top, you can't see it at the minute because I made it too big. To the right, oh, actually to the right it gives you a time frame. You can say last 24 hours, last 15 minutes. As time shifts, your graphs will update. So you can just leave them on the screen and monitor. If you expect something to be 0 all the time and it suddenly changes to 1, something's happened that you want to know about. These are my screenshots in case it didn't work. Ever the optimist. How long have we got? About 15 minutes. Yes?
Grafana, can they be used externally? Like, is there an API or something?
Well, you can put Grafana on any screen you want. People do have to be able to get to it. All of the data is stored in Elasticsearch, and that has an API. So you can use other tools like Grafana as well with it. Grafana is just the graph rendering part. So section 5, log management. Some of you may have heard of Asimov's law of robotics. A robot may not injure a human being may not injure a human being or through an action allow a human being to come to harm. I have a similar one for application logs. An application log may not injure an application's performance or readability. Logs are supposed to help us, not make it difficult to work on the code base. I remember once I was working on the project and we started, I think it was using MongoDB actually, and we weren't getting the performance we wanted. So we started to log the time it took each query to execute. And we logged that to a MySQL database. And it started to do it great. We started to make optimizations, but then over time, page responses started to get slower and slower and slower. It turns out that it was taking more time to log the time taken for the query to MySQL than it was to run the initial query. That was a fun one. And else when I'm working on the project where for every line of code there were 2 or 3 log messages, and they just made it a nightmare to work out what was actually going on. Logs are supposed to help, not hinder. So they can't injure an application's performance or readability. Those are the only 2 rules. As your application grows, so does the amount of data. It's easy to get started, it's harder to scale that. But you need to make sure you can handle bursts of data, because when do you get the most data? When something goes wrong. And when are logs the most useful? When something goes wrong. So if something goes wrong and your logging system blows up and you don't have any logs, what use is that? You don't care about the logs when everything's working. Disk space. This is seems like a simple one, but it's the #1 cause of application failure. You log into disk, you run out of disk space. I alluded to this one earlier with Elasticsearch. Elasticsearch stores data in what's called an index. It's normally date sharded. But imagine that you've got one application that sends a ton of data that isn't really that important, or one application that doesn't really say much, but when it does, you really have to listen. Because Elasticsearch is a circular buffer to store it, as you get more data, the oldest data is erased, it's overwritten. Actually, I don't think that's by default. I think that's something that we always just configured. But if you do have a high volume feed, tag it with something, send it to a different index, or tag your important ones. You can set custom retention policies. You can say, this high volume feed, I actually only want to keep 3 days worth of that. But this really important one, I want to keep 12 months. By working out what logs are important to you and tagging them as such, you can make sure that you keep the information that you need. Ship what's relevant, and this one's down to you. If your Logstash nodes are overworked, don't send it debug logs. This might involve writing 2 separate logs to disk, one for debug and one for error. So you can always go back and look on disk if you need to. But if disk space is at premium, ship them, then let Logstash strip them out. It's a trade-off that only you can decide on. Every feature that goes to production must have a set of grok patterns, if necessary. Ideally, we're just emitting JSON anyway. It's got to have a dashboard that we can look at, work out whether it's behaving as intended. It's got to have a set of alerts. When devs are involved in thinking about how something will be monitored at development time, the instrumentation ends up being way better. If before you start writing any code you think, how do I know if this is working? What's going to happen when it's not? How will I know that? You can instrument your code for that. Make sure each request has a unique ID so that you can trace that request through your entire system. You might generate this yourself at your entry point at your API. If you make calls to internal APIs, pass it along. You want to correlate all of those log events to a single request. If you don't want to generate it yourself, use something like Varnish's ID header. It doesn't matter where it comes from, so long as you have one. And finally, normalize time zones to UTC, or use timestamps. I don't care which. This needs a second slide, just because people say, yeah, I've got that, but they don't. And then they come to use their logs, and they think, well, why did this happen? It says it did that, but that happened before it, but it can't, because that told that to do that. And it turns out they're just in different time zones. One's running on the east coast of the US, one's running on the west coast. Stick to UTC, otherwise you're in for a world of pain. Almost there. Almost time for beer. I'm going to quickly run through a couple of supporting tools. I mentioned Filebeat earlier. It's a lightweight alternative to Logstash by the same company. This one's written in Go rather than Java. As of version 5, it has some data manipulation tools, but they're nothing compared to Logstash's. So you can use this to ship logs off your nodes to a central Logstash instance, which then processes them and sends them on. Or if you don't even need to do that, you can use Filebeat to send directly to Elasticsearch. This should be run on every node. It should be looking at log files, shipping them off to either Logstash or Elasticsearch. We have Graphite, which is a time series database for recording events. I would like to change this and say use Prometheus instead. But Graphite's fine to get started with. And this is for things that don't need much context. Like we saw the log messages, they had a ton of metadata. This is for when you just need to know it happened. You can send data to it from your application, or you can use Logstash's Graphite output. But what you end up with is something that looks like this. And it's great for spotting patterns. This graph, and you probably have no idea what it does. I know what it does. It tracks data input versus data output from the process. We expect every item that comes in, we do a little bit of processing and augmentation, then we want to send it out again. So we expect the blue and the yellow lines to match up. Not exactly, but close enough. And as you can see, they're pretty much there. If the yellow line dropped dramatically, I'd know something was wrong. This one's a graph of system loads per minute. If one server spikes, you're going to notice it. Like, it's useless right now. Like, you don't care, but it's between 0.1 and 0.4. That's fine. If something shoots to 10, everything else is going to shrink down. You can see one big spike. It's about the shape of the data, not necessarily the values. And seeing that shape makes you more informed. You can use Grafana to talk to Graphite. Graphite's a data source. You can use Grafana to talk to Elasticsearch rather than Kibana. It's just a graphing tool. And as you can see, it can draw much prettier graphs. Pagerduty. This is important. This is what tells you when something isn't quite right. You can trigger alerts based on data in Kibana and Graphite. If a system's load average spikes above 10, you want to know about it. But you need to trigger that alert somehow. And for me, the best one I found is a tool called 411 from Etsy. And you can set up rules that say, alert me when there are X events in Y time. And that can be, alert me when there is one event ever, or alert me when I see 10 couldn't connect to databases in 3 minutes. You can set those thresholds yourself. You can say, alert me when our request per second goes outside of one standard deviation, or when it drops by more than 10%. You can trigger a lot of alerting systems, such as email, Slack, and of course, PagerDuty. Finally, our conclusion, almost there. I know it's been a long day. Logging is required. It's not optional. We need to know what's happening inside our applications. Like, we have to. It's not a question of should we, it's a question of how we. And the key to this is that developers are empowered. You should be the ones doing this work. It shouldn't be your operations team. They're the ones that, developers are the ones that know how an application should work. They're the ones that need to expose the relevant information. All the operations team should be doing is setting the alerts in production based on the values that the developers gave them. And we do need to be aware that logging does have a performance impact. It's code that's got to run after all. For example, we compile debug statements out of some of our core C++ systems because even just doing the check to say, should I log? No. Slowed it down too much. And we actually had to compile that code out. But if you stick to info and above, that generally gives you enough information to work out what's going on when you need it, without having too much of an impact on your production systems. In the end, it's down to you to decide how much logging you need. Everyone's got a different situation, different set of circumstances. You've got to do what's right for you. But think about it. Like, I flew here. I live just outside of London in the UK. I'm sure that some of you flew here to get here too. And imagine if you, as you were getting on the plane, stewardess said to you, right, I've got a choice for you. We're going to get you there, but we're going to either fly slowly or we can fly blind. Like, we'll get there much faster if we blindfold the pilot. But which would you choose? Yeah, sure you would. And the same is true for logging. Without visibility into what our application is doing, we are flying blind. And with that, we're done. I've been Michael. You've been awesome. Like the audience participation. I know it's late. I would do questions now, but just come and find me afterwards. I'm sure everyone just wants to get out and get a drink. Thank you very much.